introduction, we are also going to see probability of an event. That is, after looking at the terminologies where event was a term in the terminologies or the terms, we want to look at probability of event. This time I will narrow it to event. Now, probability is what we are looking at. So we want to just go through probability where events are occurring or events are parts. Now, this here will give us the general formula. This here will now give birth to what we call the general formula of probability. Good. Now, this is how it is done. Probability of an event has a symbol. Now, look, in mathematically, this is a symbol for probability of an event. P of E. So, let me do it well. P of E, where P is probability and E is the event. So, probability of an event. Now, this is a formula, so equal. The formula is giving us the number of ways the event can occur. So, the top part is number of ways the event can occur. So the numerator part will talk about the number of ways the event can occur, divided by or all over the total number of possible outcomes. And of course, if you are very good, or you follow this in our videos, you realize that number of ways the event will occur. We'll talk about all the different ways events can occur. Okay, I'll teach you how to do that with symbol very soon. Then the total number of possible outcomes, we'll talk about the sample space, because we know that the total number of possible outcomes is always a sample space. So this is the, let's say, the word version of the formula. Now let's go to the symbol version of the formula. So probability of an event in symbol form, still P for probability, E for event. So probability of event is equal to number of ways the event can occur. Let me draw the line well. I'll give that one as P, N of E. N of E. Number of ways the event will occur. So N for number and E for event. So the number of the events, or the number of ways the event can occur, over the total number of possible outcomes become N of S. Of course, the total number of possible outcomes is the sample space. So in effect, the probability formula is P of E is equal to number of events over number of sample space. So this here becomes the general formula for probability. So we are going to use this formula for the meantime. So for the meantime, we are going to use this formula in our probability. So probability of an event is called number of events over the number of sample space. Now, I'm going to take some illustrative examples where this formula will be used to solve the question, so that you understand how to use this formula. Remember, this is a general formula for probability. Keep this in your mind. Let's solve some questions with it. So after looking at the general formula for the probability, we want to now take an example to just illustrate how to use the formula. So still on the probability of an event, we are taking example 1. Let's read the question. It says that a number is chosen at random from the set S 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Find the probability that the number is I odd, I even, I less than 8, IV more than 4, and then between 2 and 7. So here the question is trying to give us, or the questioner has given us an S as a set of numbers, and the numbers are in there. So let's see solution. So the S is a symbol or the representation for the set, and the numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Instantly, we'll be able to see the number of numbers in here, also referred to as what? All the possible outcomes, which is our sample space. Don't forget. So clearly, after listing them, you realize that you get your sample space directly. So here, our total possible outcome, also called sample space. Total possible outcome is also the sample space. We are getting 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We are getting 10 numbers in the set. Total possible outcome gives you how many numbers are we talking about. And that is what we refer to as a sample space. Don't forget. And that value here is 10. That is the value for the sample space is 10. Now let's continue. It says that a number is chosen at random, meaning that we are going to choose a number here randomly. That is not being biased. Selection without being biased. Or selecting the number without being biased. So here we don't want to be biased. We are selecting a number or choosing a number at random. And it says that find the probability. Say what shows that you chose I, an odd number. So the event right now is odd number. So let's start from I, odd number, odd number. That is, the number is odd. Now let's look for all the odd numbers. Odd. With the odd, we are seeing numbers that are not divisible by 2. If you know an odd number, you should know the definition right now. Any number here that 2 cannot divide, that is a value 2 cannot divide here, it's an odd number. So you know it. So help me select the odd numbers. 1 is an odd number, so 1. 2 is not an odd number because 2 is divisible by 2. 3 is an odd number because it is not divisible by 2. 4 is not an odd number because 4 can be divided by 2. So 5 is an odd number. So 5. 6, no. 7 is an odd number. 8, not an odd number. And 9 is an odd number. 10 is not an odd number. So these are the odd numbers we have. The next thing you do is get the number of odd numbers. You have listed the odd numbers. It's good. Now get the number. How many are they? So number, n for number of odd numbers. So n of odd meaning number of odd numbers. How many are they? 1, 2, 3, 4, 5. There are 5 of them. So 5 odd numbers. Now you have been able to get all the parameters for the formula. So let's get a probability of odd numbers. Remember, probability of odd numbers will depict the general formula called probability of an event. Remember, the event is odd here. It's odd. That is odd number. The event is odd. Remember, the event says number of event. Probability of event has the formula number of event divided by the number of sample space or the total number of possible outcome. So per this formula, we are going to create the same thing for odd. So probability of odd is what we call probability of the event. Equal to sign, so equal to sign. The number of the event. Instead of us to write the number of the event, we won't write the number of the event because you know the event as odd. So claim the event here and write odd. I believe you have now seen the way it looks like. And here will be the number of sample space. Of course, the number of sample space here is still the same number of sample space because the sample space is 10. The sample space is like a constant for all the events we ask for. The sample space is 10. So let's do the substitution. So probability of odd. This time around, number of odd is 5. It's right here, 5. So 5 divided by number of sample space is 10. So number of sample space is 10. So 10. You can choose to reduce it. So by further reduction, 5 over 10, 5 goes here 1, 5 goes here 2, will give us 1 over 2, which is 0.5. So you can get a final answer 0.5. So 0.5. So meaning that in conclusion, probability of the odd is 0.5. One thing I want you to know is probability values or probability final answer is between 0 and 1. Between 0 and 1. So the answers are between 0 and 1. That means that it can be less than 0. That is negative. You can never get a negative number for probability. So note, no negative answer for probability. And also you can't get more than 1 as an answer for probability. So it's either between 0 and 1. 0 means the probability cannot occur, and 1 means the probability is certain to occur. So 0 to 1, between 0 and 1 are the answers. That's why I'm getting 0.5 here. So 0 to 1 means 0.1, 0.2, 0.3, 0.4 to 0.9. And that brings us to 1. Are you getting the whole thing? So 0.5 is correct. Let's look at the second one. It says that even. The second event is even. That is even numbers. Even numbers. So I. We are talking about when the event is even numbers. Even. Now let's see how many even numbers do we have. We have 2 as even. From there 4 is even. 6 is even. 8 is even. And 10 is even. It is simple. The even numbers are the numbers that are divisible by 2. If an odd number is not divisible by 2, then an even number is divisible by 2. So 2 can be divided by 2, 4 can be divided by 2, 6 can be divided by 2, 8 can be divided by 2, and 10 can be divided by 2. So they are even. Now let's take the number of even. N of even means number of even, meaning how many even numbers are here. N of even, number of even. Let's count them. 1, 2, 3, 4, 5. So we have 5 even numbers, of course, just like the odd numbers. We have 5. Now the question was probability of even. So let's answer that. Probability of even. Probability of even. Giving us the same formula for the odd. Probability of even means that the event here is even. So how many even are there? The number of even. The number of even over the number of sample space, which of course is a constant number we know as 10. So the same formula for the general form. Probability of an event, the event is even, is equal to the number of events, which is even, over the number of sample space. Let's go. So probability of even will now give us how many even numbers are there. We have 5 over the sample space. Sample space here is 10. So 10, reducing it to 1 on 2. When you reduce 5 over 10, you get 1 on 2, giving us 0.5 as our decimal. So please, these are the examples for odd and even. Now let's see less than 8. Less than 8. Please let me clean the I. Okay, I can clean the I and do the less than 8. Let's clean the I. We'll do the less than 8. Let's clean the I. Let's do less than, so that is an I. So less than 8. That is to say, find the probability that the number is less than 8. That is the chosen number at random is less than 8. So what do you mean by less than 8? If something is less than 8, it means 8 is bigger than that thing. Or if a number is less than 8, meaning 8 as a number is bigger than the number we are talking about. So 8 is bigger than that number. Of course, we can't go here because 9 is even bigger than 8. So when you're talking about less than 8, it means that those who are below 8. So all those below 8, 7, 6, 5, 4, 3, 2, 1, they are all below 8. Also, they are called less than 8. Please, I believe you get it. So less than 8. So let's list them. Less than 8, I have 1. 1 is less than 8. 2 is less than 8. 3 is less than 8. 4 is less than 8. 5 is less than 8. 6 is less than, and of course 7 is less than 8. So those numbers are not up to 8. They are not equal to 8. That's what I mean. So they are below or less than 8. Good. So we have them 1, 2, 3, 4, 5, 6, and 7. So how many are they? Number of less than 8. Less than 8. How many numbers are there? We have 1, 2, 3, 4, 5, 6, 7. There are 7 of them. Now that we have the number less than 8, now let's get the probability of less than 8. P of less than 8. That is probability of less than 8. Probability of less than 8. It will give us how many numbers are less than 8? 7. So number of less than 8 is 7. This one, let's go. Let's just write it because we as of now we should know what value we have here. Then the down here will be the sample space, the total. Of course, the total is 10, so over 10, which will give us rise to a decimal called 0.7. 0.7. Let's do the more than 4. Then I'll leave the last one with you. So more than 4, Ivan, more than 4. So let's list more than 4. So more than 4. More than 4, I'll put it here. What values are more than? More than 4 means that they are above 4. They are bigger than 4. Those values are bigger than 4. When we say 4 here, What are the values bigger than 4? Of course, 5 is more than 4, 6 is more than 4, 7 is more than 4, 8 is more than 4, 9 and 10, they are all more than 4. So let's list them. 5, 6, 7, 8, 9, 10. So this should tell you that the event cannot be one. Event can be more, as I said, it can be multiple events and single events. So when you say more than 4, it is not a single event, it's a multiple event. So keep that. When I did that in the introduction for you, I talked about multiple event and single event. So this is an example of multiple event. All that we did are examples of multiple event because not a single number was selected. There were range of numbers selected. So they are called multiple events. Numbers more than 4, they are many. So let's see the number. The number becomes the number of more than 4. More than 4. It becomes how many? 1, 2, 3, 4, 5, 6. 6 of them are more than 4. Now let's get a probability. Let me clean this one. Let's clean here and get a probability. So the probability of more than 4, P of more than 4, will give us how many numbers are more than 4. Of course, 6 numbers are more than 4 divided by total number, which is our sample space, as 10. When we reduce this, we take 2 as a common factor. 2 goes here, 3, 2 goes into 10, 2 goes into 10 as what? 5. And 3 over 5, of course, is 0.6. So more than 4, the decimal part to be 0.6, more than 4. Now let's take the last one. Then do the last one. Try the last one for me. Let me see. Pause the video and try the last one. Okay, so let's see the answer you get. More than 4. We go straight. It's between 2 and then P of between 2 and 7. Try and see whether you get the answer. So you pause the video and try that one. Let's see whether you get the answer. So between 2 and 7, we are talking about P of between 2 and 7. P of between 2 and 7. How many numbers are there? Let's look at between 2 and 7. Between 2 and 7, the numbers in between them, that means 2 is not part and 7 is not part. So 2 and 7 are excluded. So exclusively. So they are excluded. So let's see, between it's 3, 4, 5, 6. How many are they? 1. So 3, 4, 5, 6. Yeah, 1, 2, 3, 4. 4 of them. So 4 are the number of the events we have between 2 and 7. And what is the sample space? Of course, total number becomes 10. So giving us 2 on 5, and 2 on 5 of course is 0.4. So if you got the answer, then you clap for yourselves. You have done well. Now, ladies and gentlemen, this is a question we want to solve. Let us take the second question too and try. So let's look at the second question, the probability of an event examples. So second question, let's read. A bag contains 50 identical balls, 20 of which are green and the rest red. Find the probability of picking at random a red ball from the bag. So this is just a normal question for probability of an event. So the event here, at the end of the day, you see that we want to pick a red ball. So find the probability of picking a red ball. So the red ball becomes our event. But before that, let's put down the data, the parameter for the data. Let's put down the whole thing. So solution. Now it says that a bag contains 50 identical balls. So the total number of balls. Total number of balls. Of course, that is what we call our sample space or our possible outcomes. 50. So don't forget, the total number of the balls in the bag becomes our possible outcome. So that is 50, because that's the total possible outcome. So n of s, the sample space then becomes 50, because if the possible outcome is a number of sample space, then the sample space is 50. I hope you get that one. Okay, let's continue. Now it says that 20 of which are green. So number of green balls. So green balls. So number of green balls. Number of green balls. Okay, I'll call that one n of green. Let me use green so that you see green. You can also use J, just J. I mean n of J. J to represent the green. J to represent the green. But I want to write the full word for now. So number of green, how many greens do we have? We have 20 green balls. So, and the rest red. The rest means that when the green is taken out of the total, the rest will be the red. So the number of red balls, so red balls, which is n of red. Look at this, the total is 50. So it will be 50 minus the green, which will then give us 30. So the number of red balls are 30 because the total is 50 and we know part of it, which is green, as 20. So when we subtract the 20 from the 50 as total, we should get the rest, and the rest is our red. So red will be 50 minus 20, which is 30. So put down that particular calculation so that you can remember. Now let's go on. It says that find the probability of picking at random a red ball from the back. This is a probability question because of that word probability. It says that what shows that we pick the red ball. So the event here is the red ball. So don't forget, we want the probability of picking red. So our event is red. From the general formula, probability of event is equal to the number of the event over the number of the sample space. How many occurrence of the event, or the number of occurrence of the event, or the number of times the event occurs over the total possible outcome, that is the sample space. So this is the formula for probability. Number of the events over the total number of sample space. What is the event? The event is red. So here, instead of us to write number of the event, we write number of red because the event is red. The event is red. Over the number of sample space. Of course, the sample space is simple. It's always a total. So for sample space, we still maintain this as sample space. Now let's put the values in there. Let's put the values. So what is the number of red? Number of red, of course, the number of red is here. Number of red, we calculated this as 30. And then what is the number of, so 30 up here, number of red is 30. Number of sample space, when you look at the sample space is 50. So bring it here, 50. Now reducing this will give us 3 over 5. And reducing 3 over 5 will get 0.6. So we get 0.6 as our decimal, 0.6. So ladies and gentlemen, the probability of red is 0.6. Please pause the video and go through well. Thank you. This is the third question for probability of an event, and this will be my last question for you, but we'll give you some questions to try. I'll give you some trial question at the end of this video. I'll give you some trial questions. Then we can now pick events by event and look at how their probabilities work before we can even look at other formula or other laws of probability. Now let's read the question. It says, in a class of 70 students, 40 of them are girls and 30 of them are boys. A student is selected at random from the class. What is the probability that the student is a girl? Let's put the data down. Solution. As of now, you know how to write data when it comes to probability. It says that in a class of 70 students, so this will be my sample space. In as much as we want to write the full, so total number of students. Total number of students. That is what we call N of S. Don't forget the symbol and the probabilities N of S. That will be the total number of possible outcomes. That is what we refer to as a sample space. Here it becomes our total number of students. Don't forget that. It is 70. Good. We go on to say 40 of them are girls. So number of girls, or total number of girls. Number of girls. Number of girls. I use the symbol N of G. G for girls. Okay. G for girls, or you can say girls. You can write the girls there. G for girls. Total number of girls become 40. And then number of boys. That is the total number of boys. Number of boys. So I'll use N of B. B for boys. It will become 30. So B for boys, G for girls, and S for sample space. So number of boys, number of girls can still be referred to as the total number of boys or the total number of girls. Let's continue. It says that what is the probability that the student is a girl? So the event is a girl. Don't forget, the event is a girl. So probability of a girl, that is the probability of the event. From the formula, realize that it will be the number of girls over the total number of sample space, right from the general formula for probability of the event. When you know the event, it says that how many of the events are there, which is called number of the events, over the total number of sample space. So this is the general formula of probability. But here we know the event is girls, so I use J for girls. So P of J represents P of the event, and the equal sign will come. Number of girls represent number of the event, and then number of sample space, of course, number of sample space. The reason why sample space is always there is because the sample space becomes a total number, which is still a constant, always given in the question. Are you getting it? So now let's put the answers there. So now probability of getting a girl. Probability of girls will now become, let's draw the division line. Number of girls alone is 40. So don't forget, in place of n of g, number of girls, we put 40 because that is 40. Then here, denominator here, number of sample space, of course, number of sample space is 70. Number of sample space is 70, so 70 down here. Please, you can reduce this further. 40 over 70 will be reduced to 4 over 7. 4 over 7, the decimal form will be 0.571. So the decimal for 4 over 7 will be 0.571. So this will be my final answer for probability of girls. That's how it's going to be. So ladies and gentlemen, you watching me out there, you have seen how probability is done. This is just the beginning. We are going to solve more questions on the probability, but we are pleading with you, and we beg you, make sure you understand everything that is going on. Anything that you want to ask, please leave it in the comment section. Give us comments on this video. Don't forget to like the video. Just click on the like button. Share our videos to all your friends, especially those in the senior high schools. And also, we are begging you that you subscribe to our channel. Subscribe so that we can prompt you, or you can get a notification anytime new videos are uploaded. Click on the bell icon. Don't forget to click on the bell icon. It's here that we are going to leave the whole thing. We are going to end the probability here for now. We'll continue with the event on probability at the right time. We'll come your way, same time, and then the same place with our video on Call Maths tutorials. My name is Anthony Osei Mensah. I'll see you again in the next video. Thank you very much. God bless you all. Safe. Alright. Please subscribe to our channel and click on the bell icon to get a notification anytime we upload a new video. Also, don't forget to like, share the video, and leave your comment in the comment section. Thank you very much. God bless you all, and take care.